Hello, this is Satbir. In this video, we will learn how to calculate the derivative of a logarithmic function. We will begin this lecture with calculating the derivative of natural log of x. The formula for calculating the derivative of natural log of x is here. It says that the derivative of the natural log is simply 1 over x. We will practice this rule with various examples. So my first example is calculating the derivative of natural log square root of x square plus 1. Before I calculate the derivative of this function, I will simplify the function first. So this function can be written as a natural log of x square plus 1 to the power 1 half. Since 1 half is in the exponent and logarithm has a property that the exponent can be flipped over the natural log. So this will be natural log of x square plus 1. So now I have a simpler version of the function. I will calculate the derivative of this function. As we can see, this function is the composition of the function x square plus 1 and natural log of x. And x square plus 1 is sitting inside of the natural log. So we have to use the chain rule to calculate the derivative of this function. So to use the chain rule, I will make it the substitution u as the inside function x square plus 1. And I will calculate the derivative of this function. This will be du over dx, which will give me 2x. So if I make my substitution u as x square plus y, then my y function will become 1 half natural log of u. So if I take the derivative of this function y with respect to u by using the formula above, it will be 1 half is a constant which multiply to the derivative of natural log of u, which is a 1 over u. Now I will apply the chain rule to finish this problem. Apply the chain rule. So chain rule say the derivative of the function with respect to x is a multiplication of the derivative of the function with respect to u times the derivative of u with respect to x. It's the product of two derivatives which we have just calculated here. So we multiply this one. This is a 1 half 2u multiplied to 2x. If I simplify this expression, I will get, because 1 half and 2 will cancel to 1. So it's going to be a x divided by u. I would like to have my answer only in x because my function is in x. So I should have my answer also written in x. So I will replace my u from here, which is the x square plus 1. So x square plus 1. So that's your final answer to that problem, which is here. Let's take one more problem and practice this rule. Here I have a problem. In this problems, I will use the chain rule twice because there are three chains inside of that function. And here my substitution will be u is equal to natural log of 2x. And therefore my y function will become natural log of u. And I need to compute the derivative of du with respect to x, but here I can see that this is the inside function, that is the outside function, so I have used to use the chain rule. If I take this function as a v, and then this is basically function will become the natural log of v, which is a 1 over v times the derivative of v. So that is the chain. If I take my v as 2x, so it will be basically dy by dx 2x divided by 2x, which is derivative of 2x is a 2 and derivative denominator function is a 2x. So if I simplify this one, this will be 1 over x. And now I will calculate the derivative of y with respect to u, which is a simply 1 over u with respect to u. To finish this problem off, I will apply the chain rule. The chain rule say the derivative of the function y with respect to x is dy with respect to u times du with respect to x. So we will multiply the derivative of dy with respect to u, which is a 1 over u, with the derivative of du dx, which is a 1 over x. So I will multiply both these terms. And since I would like to have my answer all in x, so I will replace u. What is a u? Natural log of 2x multiplied by x. I will multiply x here. So that's my final answer. Now let's take one more problem. So here I have a problem, natural log of 2 plus square root of x. So in order to use the expedite our calculation process, uh, now on we will use this formula dx, the derivative of natural log of u with respect to x is du dx, which is basically inside function divided by u. So here you can see your u is, this is your function u. So the derivative of this function dy dx will be just d over dx of u, which is a 2 plus square root of x, divided by u, which is a 2 plus square root of x. And then I will calculate the derivative of the top, which is a 0 plus 1 half x to the power negative 1 half, and divide by 2 plus square root of x. If I simplify this expression, it will give me 1 over 2 square root of x, because the exponent is negative. I will move that into the denominator, and it will multiply to 2 square root of x. This is your final answer for that problem. I have one more problem. So the derivative solution to that problem is going to be the similar way, the derivative of dy with respect to dx. So here, this is your u. So it will be, so derivative d over dx of u, which is x plus 1, divided by the derivative of square root of x minus 2. Divide by u. What is a u? X plus 1, whole entire thing is divided by x minus 2. Now we have to calculate the derivative of the top term, x plus 1 square root of x plus 2. Since this is a quotient of two function, we will use the quotient rule and write down here. So how the quotient rule work? You can watch the previous videos on the quotient rule, but I can write it here. So the derivative of the top is 1. We calculate the derivative of the top. The derivative of the bottom is 1 half x minus 2 to the power minus 1 half. And then we do read that chanting low d high, high d low. So low multiply to high. Low function is a square root of x minus 2 is multiplied to high, which is a 1, minus high multiplied to low. X plus 1 is multiplying to low, which is a 1 half square root of, which is a 1 half x to the power x minus 2 to the power negative 1 half. Whole entire thing is divided by low, which is a x minus 2 square root of that, the square of that. And this whole entire thing is divided by this function, x plus 1 divided by square root of x minus 2. So this is a lot here, but that's your final solutions. You can simplify if you want. I can give you the simplified version of the solution. of this problem, which is this. After simplification, you will get x minus 5, 2x plus 1 square root of x 1 1 by simplifying this complicated expression. Next, the derivative of the logarithm function, which has a base b, is given by this formula. The formula is 1 over x times the natural log of b. So we will use this formula also, that if we are calculating a dx over d, some function, we will use this formula for faster calculation. Sorry, this one is log of b of u will be basically 1 over natural log of b multiplied by u and the derivative of u on the top. So again, to this problem, dy by dx, so derivative will be the derivative of inside function. We take the derivative of inside function, which is x square plus 1 to the power 1/2, and divide by this function, multiply by natural log of 10, because base is 10 here, and multiply by u, because u function is this. So I will have x square plus 1. So the derivative, this is going to be a 1/2 x square plus 1 to the power negative 1/2. It is a divide by natural log of 10 and square root of x square plus 1. So the exponent is a negative. I can move that thing into the denominator. So it's going to be a 2 natural log of 10 square root of x square plus 1 times square root of x square plus 1, which will simplify to 2 natural log of 10 x square plus 1. Because 1/2 times 1/2 is 1. That's complete the problem here. I have two more problem for you to practice. The very first quiz is, what is the derivative of this function natural log of pi? You can leave your answer here in the link above to compare your answer with the other people. And there is a quiz number 2 question, which is the derivative of natural log of x square plus 1.